Okay, chapter 19, part 3. I wanted to end on this last bullet. So, abnormal rates of mitosis can lead to cancer. So, I know students often will ask, well, what causes cancer? So, anything that is a carcinogen, anything that has the ability to mutate your DNA. So, that's things from high concentration of x-rays, that's to things like asbestos, that's things like tobacco and the other products that are in cigarettes. So when you think of carcinogens, things that are cancer causing, what they're actually doing is increasing the rate of mutation. So we know that there are those checkpoints. Remember, G1, G2, important checkpoints. And so we can increase our incidence of abnormalities or mutations by exposing ourselves to high amounts of carcinogens. Another big one, of course, sun, thinking about sunlight, UV damage to our DNA and our skin cells, which can lead to myeloma. So things like that. So I'm going to pause a second and then I'm going to go to the slide that I want to start on next. Okay, so another thing that can happen is that we can have changes in chromosome number. So in an ideal world, you have 23 chromosomes from mom, so one set from mom, 23 chromosomes from dad, or another set from dad. But sometimes what happens is that an individual can inherit too many or too few, both autosomes, 1 through 22, or sex chromosomes. And this is caused by a phenomena called non-disjunction. So non-disjunction occurs in meiosis 1 or 2, and essentially what we see in meiosis 1 is that those homologous chromosomes that are lined up all pretty and there was a synapsis and they were crossing over and exchanging little bits of their genetic material. So it can be that they don't separate correctly during meiosis 1. So you don't get this like it should, right? You could get it like this. It can also happen in meiosis 2. Again, I'm thinking what we call benephase 2, so that's in meiosis 2, where you have those sister chromatids, and for some reason those sister chromatids aren't separating appropriately, so you either give 2 to one of the resulting cells or you give none to the other one. So let's take a look at some examples. Trisomy, you might have heard of trisomy 21, which is another name for Down syndrome. It's the genetic underlying reason for Down syndrome. So essentially you have 3 copies of chromosome 21. Trisomy generally happens only with the smaller chromosomes. The bigger chromosomes would not produce a viable fetus. So generally there's a spontaneous miscarriage or like chemical pregnancy and then, a miscarriage afterward. Now, the other condition is monosomy. So too few chromosomes means that you have one less than you're supposed to have. So we can take a look at Turner syndrome, for example, is a condition with a sex chromosome where a woman can be genetically female just with one X chromosome. The other one forms what they call the Barr body. So you can survive and just have one copy of an X because all you need is one copy of an X. Males only have one copy of an X. So that can be monosomy. So let's take a look at what this looks like. Okay, so if we have non-disjunction in meiosis 1, we see that these homologous chromosomes fail to separate. They go through meiosis 2. So we see that essentially we have too many. And then when we go ahead and finish meiosis 2, then, when we finish meiosis 2, we have 2 copies of the same chromosome. We really should just have 1. And when this is fertilized with the sperm, which is here, they're showing it with the blue chromosome. Now we have 2 copies of this chromosome in red from mom and 1 from dad. So this particular zygote is going to have 2N plus 1 and 2N plus 1. And then this one's going to be short, the chromosome, right? You see that? It's just got the 1. So that's one way of getting non-disjunction where you're lacking the chromosome is essentially the sperm fertilized an egg that didn't have a copy of that chromosome. Okay, it could happen in meiosis 2. So we see that meiosis 1 was normal. So we finish meiosis 1 with this sister chromatid. And then we go to split this in essentially metaphase 2. And this one looks beautiful, but this one didn't separate properly. So now we have 2 copies in this particular cell, and we have none here. So if a sperm fertilizes this one, then it just ends up with 1 copy of 1 chromosome. It doesn't have the other one, so the red one is missing. Here it has an extra red one, and then these 2 are normal. So it just kind of gives you an idea how that occurs. Okay, so an abnormal number of autosomes causes developmental abnormality. So I'm thinking trisomy 21. Monosomy of all but the X chromosome is fatal. So you can't live with just 1 copy of a 1 or a 2 or a 4 or 22. So the only way that you can be monosomy is if you're XO, Turner syndrome, and you have 1 copy of an X, and that works. Trisomy is usually fatal, except for the tiniest of little chromosomes, particularly 21. So we know they have a high chance of survival and can have a really good life. Okay, changes in chromosome number. So this is talking specifically about the sex chromosome. So let's just go ahead and take a look at some of these in a moment. And then we can see all extra X chromosomes become bar bodies. So you can technically be poly-X. So you can be XXX. All you needed was 1 X. The other 2 become bar bodies. And then you can be XXY. That second X becomes essentially equivalent to a bar body. So you can actually have an extra copy of an X, and with a Y, you're still male. You can have an extra copy of a Y chromosome called Jakob syndrome. And it's survivable because the Y chromosome is the tiniest of all chromosomes, and there's not much on it anyway. Okay. So here's some disorders that you should familiarize yourself with so you know about Down syndrome. Turner syndrome, female, generally short stature, broad chest, maybe some folds on the skin of the back of the neck, doesn't have to be, and generally sterile. May have some developmental delays, but not necessarily always. Then we have Klinefelters, so this is XXY, so you're genetically a male, you have 2 copies of an X with the Y. Klinefelters, males tend to be, maybe have some developmental delays, but testes and prostate gland are underdeveloped, no facial hair, maybe some breast development, large hands and feet, and long arms and legs. Here we see the karyotype. Remember a karyotype? We see 3 copies of the chromosome 21. Poly-X, I believe I just talked about that. Poly-X females will have children that are normal karyotype. So it's not going to be something that she's passing on. And females with more than 3 chromosomes are very rare. A couple other things here. Jacob's syndrome XYY. These males tend to be taller than average, persistent acne, maybe have some speech and reading delays. They are fertile and can have children. Okay, so let's go back to changes in chromosome number and also the idea of what causes cells to become cancer. So we're thinking about environmental agents. I know I talked about carcinogens. Here's some other things, radiation, organic chemicals. Something that could affect your chromosome structure, of course, viruses are able to do that. And so if we're breaking apart pieces of our chromosome, they can reattach to other pieces, and that kind of messes things up. So that's it for chapter 19. I'll see you in my next set of videos. Have a good week.